If you're building anything with LLMs, you know the feeling. You tweak a prompt, you change a model, and you think it's better. But how do you actually prove it? Well, today we're diving into a super practical way to answer that exact question using an awesome open source tool called DeepEval. So here's our game plan. We'll start by digging into why evaluating these models is such a headache in the first place. Then, we'll introduce DeepEval's killer feature, build our own custom test from scratch, look at some specialized tools for RAG, and finally, put it all into practice with a real-world model shootout. Okay, so you've built your amazing new app. It seems to work, but seems doesn't cut it when you're trying to improve things, right? How can you tell if your latest genius prompt engineering actually made a difference? Because the old ways of testing software, they just don't work here. Let's start with a ridiculously simple question. To you and me, the answer is obvious. But for an LLM, well, there are a whole lot of ways to be right. Now look at this. Every single one of these actual outputs is totally correct, right? A human gets that instantly. But if you were just doing a simple text check against 2.5, almost all of these would fail. And that right there is the core of the problem. We have to evaluate for meaning, not just for an exact sequence of characters. And this is exactly where DeepEval comes in with a really clever, almost poetic solution. What if we used an AI to evaluate another AI? This is the big idea, the LLM as a judge. Instead of writing a ton of complicated code, you just use a powerful model, say GPT-4, and give it instructions in plain English. You tell it what to look for, correctness, style, relevance, whatever you want. It's like having a subject matter expert grading essay instead of just running it through a spell checker. It gets the nuance.
All right, enough theory. Let's get our hands dirty and see how this actually works. We're going to build our very first evaluation metric right now and see just how powerful this is.
And you might be thinking this sounds complicated, but honestly, it's not. It all boils down to these three simple steps. First, we tell our LLM judge what good looks like. Second, we give it an example to grade. And third, we just run the test and see what it says. So here's what that looks like in code. We're creating something called a GEval metric. Now, the magic is all in that criteria string. It's literally just us talking to the model. And to start, we're being super strict. We're telling it, check if the output is exactly the same. No wiggle room. So when we run an output like the result is 2.5 against that metric, it fails. No surprise there. But here's the really cool part. DeepEval doesn't just say, nope. It gives us a reason, in plain English, telling us exactly why it failed. That is a game changer for debugging. Now watch this. All we're going to do is change that one line of plain English criteria. We tell the judge, hey, this time just focus on the meaning. Don't worry about the extra words or formatting. And boom, the exact same test now passes with a perfect score. That's the flexibility we're talking about. Okay, so making custom metrics is amazing. But what about common problems? Well, DeepEval comes with a whole toolbox of pre-built metrics, and they're especially handy for things like retrieval augmented generation, RAG systems. First up is answer relevancy. You know when you ask a chatbot a simple question and it gives you its whole life story? This metric is designed to put a stop to that. It measures how much of the answer is actually on topic versus just fluff. And the way it works is pretty clever. The LLM judge breaks the entire answer down into individual sentences or claims. Then it goes through them one by one and decides, does this actually help answer the original question? The final score is just a simple ratio. So let's take this example. You ask a straightforward question, and you get this response back. There are 4 different statements in there. But really, only one of them is the answer you were looking for, right? And bam, DeepEval correctly identifies that only one of those 4 statements was truly relevant. So it gives you a relevancy score of 25%. We've just turned that vague feeling of this chatbot is too wordy into a hard number that we can track and improve over time. Now, this faithfulness metric is super important, especially for RAG. It measures something very specific. Does the model's answer stick to the documents you gave it, even if those documents are wrong? So if we give it a document that says the capital of France is Madrid, a faithful answer is Madrid. An unfaithful answer is Paris because it's using outside knowledge. This is absolutely key to preventing hallucinations. All right, we've seen the tools, we've seen the metrics. Now let's put it all together and use them to solve a real-world problem, picking the right model for a job. Let's dive into a case study on parsing invoices. So here's the mission. We need to pull 5 specific pieces of information out of a PDF. But there's a trick. Buried in the text is a little note that says, all prices and taxes are in thousands. That means a total of 150 is actually 150,000. We're going to throw 3 different GPT models at this and see who notices the fine print.
And the results are in. It's pretty telling. All 3 models were champs at pulling out the simple text fields. Name, country, no problem. But look at the numbers. Every single one of them missed that critical note about the values being in thousands. They just read the number on the page.
So instead of just shrugging and saying, well, they kind of messed up, we can use DeepEval to turn this into cold, hard data. We'll set up a simple metric. What percentage of the fields did the model get right? Since they got 3 out of the 5 fields correct, that gives us an objective accuracy score of 60%. And that is everything. We've gone from a gut feeling to a concrete number. Now we have a baseline. We can try new prompts or other models and see if we can get that 60% to climb. So if there's one thing you take away from all this, it's that properly evaluating your LLMs isn't some dark art. It's totally doable. Using the LLM as a judge approach with tools like DeepEval, you can finally move away from guesswork and start making actual data-driven decisions to build much better and way more reliable AI applications. So I'll just leave you with this final thought. You're not just building and hoping for the best anymore. You actually have the tools to measure what matters. So the question is, which of your models is really the best for the job? And how are you going to prove it?